Welcome back to Sci-Fi versus Reality. This is episode 4, and today we're going to be looking at a space adventure book called Delta V. We have the actual author here, Daniel Suarez, to join us for a live interview. Let's get right into it.
Welcome to the podcast, Sci-Fi versus Reality.
Oh, thanks for having me.
Sure. So we're going to be talking about your book, Delta V. And the first question is just based on the actual spin gravity of the ship, the Constantine. So on their way to Ryugu, the crew of the Constantine felt more at home due to the spin gravity function of the ship. We actually talked about spin gravity in episode 2 of the podcast, focused on 2001, and it's been used in a number of movies since, but it still doesn't actually exist in reality. As an author, how much freedom did you feel you had to still play with the concept, or did you feel like it has become a trope that you had to fit within?
Actually, I think as an author, I had complete freedom, but for the story that I wanted to tell, which was a very real space adventure, I wanted it to hew to reality. And for that reason, I needed it to be very accurate. So it goes well beyond a trope. I think it's something critical that if we are going to go into space for any significant duration, it needs to be incorporated. Jim Logan, who is the former flight surgeon for NASA, he's described it this way, that we don't yet know what the minimum dose is of gravity for humans to be healthy. And that's why we need to try to experiment with spin gravity, either in cislunar orbit, close by Earth, or in this case, on this mission, they had to replicate a full Earth gravity because that was one problem they didn't want to deal with. You don't want to build a big mission plan and just assume that people can survive and thrive on 1/6 gravity, only to find out that the bone loss and muscle loss, that blood plasma flows and all sorts of things incapacitate the crew. So I don't think that I had really any freedom if I was going to make the story realistic to avoid spin gravity. I think I really needed to. We certainly don't have the ability to create gravity in the absence of an enormous mass. So spin gravity is really the only way to go. And for that reason, I made it very accurate. Both the dimensions of the ship, its spin rate, everything. So no freedom at all, actually.
Yeah, that's really interesting. I didn't really think about that. So one of my favorite parts of the book was actually the honeybee mining robots that they used on the surface of Ryugu. They're just such a crazy concept. These robots just like bouncing off the surface and bagging massive rocks. What gave you this idea?
Well, this is the other good thing is I did a great deal of research for this book. The book really, Delta V comes out of this desire to write a story. So much sci-fi takes place 300, 400, 500 years in the future. The Expanse is a good one. Or thousands of years in the future. And there's precious little sci-fi that I've read recently anyway, that deals with the gap we have to cross to get from the present to that sci-fi future we all imagine. So that's really was the impetus of this project. And so for that reason, I did a lot of research on real robots and spacecraft that exist, that either NASA has designed or other entrepreneurs have designed. And the honeybee robots are that. Now, I think actually in the question, you call it the honeybee. I think you're referring to the asteroid redirect mission robot, or the ARS robot in my story. That's the one that goes down to the surface and grabs the boulder on the surface of the asteroid and then springs away from the surface. Is that the one you're referring to?
Yes.
Okay. That is actually the ARS robot. And that is from a NASA design in, I believe it's, 2013. It was called the Asteroid Redirect Mission. That machine was being built not far from my house, at least in prototype form. It was canceled or defunded by NASA in 2017, much to my dismay. And it was going to be sent out to an asteroid and go bag a rock in exactly the way that I describe in the book. I was really saddened when that was canceled. But the honeybee robots are the optical mining robots. So these two systems work in tandem in my book. And again, right now, the honeybee robots, which are designed by TransAstra, which is a private company, they were just funded for a test in orbit by NASA to build a small test, send it up into space, and try to use its optical properties to process simulant asteroid regolith. So all of this stuff is very real. It's starting to unfold right now. So that's where I got those crazy ideas. Is I did a great deal of research to try to find, amongst all these really interesting ideas being researched by scientists and by NASA and by entrepreneurs, to find the ones that I thought were going to be the most promising, and to incorporate that in a story, to make it thrilling, and also to make it interesting so mainstream readers could read about it and understand what might be happening in the future and why it's relevant to them.
Yeah, it's just really interesting and exciting, really, to think about the fact that all the things that I've been reading about are happening now and could be in use very soon.
Oh, I'm jealous, actually. You're young, so you're going to see some really cool stuff. I'll be like, go.
So obviously, with all of your research, you wanted to make Ryugu as realistic and accurate as you could. Was the electrostatic properties of the regolith intended to be more of a plotline event, or did you want to make their experiences as close to the truth as possible?
Yeah, I kind of, I got a little carried away, if anything, with the realism. Julie Bellerose, who was a member of NASA's Cassini team, and who is an advising member of the Hayabusa team, which just recently sent a probe to Ryugu. I met with her and got her advice. I read books like this. This is a fascinating book. Oh, it's probably in mirror form on your screen, but what it says is the electrostatic phenomenon on planetary surfaces. So the electrostatic properties of airless bodies, things like that. I mean, I went into a great deal of detail on it. The other thing was I was in communication with JAXA's Hayabusa 2 team, exchanging information with some of the engineers there as Ryugu, the asteroid, was coming into focus for the first time. So I really went out on a limb here. I used all of the spectral data and all of the information that was known about this asteroid prior to their arriving with the Hayabusa 2 probe, and made my educated guesses. And fortunately, they turned out to be correct. The asteroid is, as described in the book, that is how it is in real life. And that was an exciting, a little tense time as that came into focus. But the properties of an asteroid, it is electrostatically charged. What you have is a situation where the solar wind comes in, and oddly, the dark side of an airless body in space receives the charge. So the side that's being hit with the solar wind is where it starts to accumulate, and then it starts to move around into the dark side. And of course, the asteroid is rotating, and so that's constantly changing. You have about up to 200 volts of electricity that can be on the surface. And the other thing is you can actually see dust levitating at times. What will happen is it will get in a positive electrostatic charge, and these very fine particles will start to repel each other somewhat. And so it'll create what looks like a haze. So it was a very interesting question to me anyway. And of course, I tried to incorporate that in the story. You want people to face mysteries and then have the understanding of what's going on, what the risks are. So that's really why I went to that effort.
Yeah, the research definitely paid off on that respect. I'll make sure to read that book. It sounds really interesting. So no one has ever done anything quite like the re-entry that JT and other crew members experienced towards the conclusion of the book. That was just really exciting. How did you research what would have to happen in order for them to pull that off?
I have to admit, I have a bit of an advantage here. I'm about 2 miles from the Jet Propulsion Lab, and one of my friends is a Jet Propulsion Lab physicist, a guy named Eric Burt. He's named in the acknowledgments. His mission, which was, I have to get the name exactly right, it's the Deep Space Atomic Clock, which was launched in 2019. This was a highly accurate but very compact atomic clock that went out into the solar system. The idea is to sort of begin to create a GPS system for space navigation. He was my advisor for this part. He helped to write some software to simulate the trajectories that my fictional crew was going on, and also some software to simulate the aerobraking maneuver at the end of the book. So all of that stuff, the idea of them going across 4,000 miles of atmosphere to slow down, what their deceleration Gs were going to be, the variability, the speed starting, the speed ending, all of that stuff. I was very, very fortunate to have such expert advice, and he really got into it. So I'm fortunate. So thank you again, Eric, for all that.
Yeah, that's really cool that you had someone to kind of get all that information from and just talk about it with.
I was very lucky.
So in order to create specialized tools and parts on the Constantine during the 4-year mining operation, the crew used a special 3D printer and a centrifugal distillery. What science did you base this off of, and how widely used do you think it will become in the future of space exploration and travel?
Yeah, what you're describing is something that I don't think we've really seen in at least mainstream sci-fi, certainly. But it is an idea and also a real technology that has existed since 1890, and it's called chemical vapor deposition. And the indications are it's going to be tremendously useful in space when it comes to building things out of metals, especially early on. If you're in space, you're in a microgravity environment. Typically, the spacecrafts are going to be very lightweight, and having a molten furnace, with molten metal flying around in microgravity is going to be extraordinarily dangerous. You're going to need this hardened shell or a magnetic field. There's something very complex. And the really interesting thing about chemical vapor deposition is it used to be used in the early part of last century in a lot of, oh, hang on just a moment. No. Sorry, a little distraction there. What was I saying? Yes, it was used in the early part of last century to make very precise products with really pure metal. And the way it works is you don't heat up metal and make it molten. Instead, you turn metal into a gas, and I described that process. It's surprising. It's more of a chemical reaction. It doesn't require thousands of degrees of temperature. It requires more pressure and some temperature and just the right combination of compounds, and you can make metal turn into a gas and then a liquid, and then you can do what's called depose it in the proper atmosphere on a specifically heated surface. So you can start to accrete, almost like snow in a way, except it doesn't precipitate like that. It more sort of appears out of a gas into a solid. And that is what my crew used to create very precise, hardened machine tools and equipment. And that is a very real technology. And as I said, it was used in the 1930s and 40s in the United States to make really precision equipment for factories and machinery. It just wasn't cost effective. Here on Earth, you can just heat up a big furnace and use a ton of energy and make a ton of mess. And it's not really an issue. But bringing many, many tons of that equipment up into space, at least for a while, is going to be tricky. And then, of course, you have to manage the molten material, which is very dangerous in microgravity as well. So that's why I went to that extra effort. The information that I got to do that in my book came from a book called Space Resources by John, I want to get it right here, John and Ruth Lewis. It was a book called Space Resources, Breaking the Bonds of Earth. And he is a professor emeritus, I believe it was at University of Arizona. Colorado, was it? Okay. Possibly Colorado. Really interesting book, hard to get. It was done in 1985, and all of the science is, of course, still accurate. And it's been reprinted in various forms, but hard to get a hold of. But I went the extra mile because I wanted to get it right.
Yeah, of course. So how close do you think society and space agencies are to using augmented reality, like Catalyst Corporation and the Constantine?
Yeah.
That's just a really interesting part.
The technology, for your listeners, the technology in the book is that a lot of the interfaces in the spacecraft are not a bunch of panels of buttons and switches and screens. Instead, they virtualize the interface on the ship. What this does is it saves tons of weight. It saves having to bring all of these replacement parts for switches and monitors and things like that. And instead, they project into glasses that people wear all of the controls that they would need to deal with. And because these glasses are so small, they can carry dozens and dozens of them on the ship. So if they have a malfunction, they can just either toss it away or get another one or fix it. But the idea, again, was to reduce the delta V necessary, the amount of energy you're going to need to move this ship. And by taking tons of physical components that would comprise the control interfaces of the ship, they do that. And there is no impediment to doing this, technologically speaking. We have the technology to do that right now. Based on an earlier book, my first book that I wrote, Demon, was about augmented reality. And as a result of that book, a lot of manufacturers brought me in to see what they were working on over the years. And there are some truly mind-blowing augmented reality headsets and technologies. The one I describe in the book is called software-defined light. And if you see that, and right now it's not cost-effective for consumers. But if you're talking about going up into space, 20, 30, or $50,000 for a headset is not an insurmountable obstacle. And it's just dropping how realistic this can look. So I don't think there's any real impediment to it. It's just, I think, a mindset. And that's part of what I was trying to do with this book is I really wanted to lay these ideas out there and let people see them in combination with one another and how they might function in a space mission circa 2032.
Yeah, I just find it really interesting how you weren't really thinking now, you're thinking in the future and what would be the best for space travel then, and then finding the technologies today.
Yeah, and that's really what I do with a lot of my fiction is I try to look out 10, 20, 25 years in the future and discern what seeds technologically are being planted today that will sprout and how they'll form and shape our lives, like I said, a couple of decades from now. Fortunately, I've had a pretty good track record with this. My primary purpose in writing these stories isn't prediction, but I would say it is trying to tell a gripping story, give people a glimpse of what might be coming, and maybe even influence events. Fortunately, there are scientists and other people who read my stories. Especially scientists are very often have a deep, deep knowledge about a very specific topic, but as a result, they might not know about other research that is adjacent or even on the other in some other discipline entirely and how it might relate to their work. So as an artist, I find it exciting to combine these things. And then when I get an email from a scientist saying, I had no idea about this, this is interesting, that always makes my day.
Yeah, that's really cool. When the crew of the Constantine arrived at Ryugu, they still had some challenges with how to mine the asteroid, such as you said, charged regolith, light and dark sides, solar wind, solar flares, even micrometeorites. Are all of these challenges based on scientific fact that you found, or did you kind of build them up for more dramatic effect?
Yeah, I could see that in a typical story. I think you would. If anything, what I did was I reduced the subset of things that they're going to face because somebody described it like this: space is always trying to kill you, and so you're constantly every assumption you have, every assumption we have about life here is thrown out the window there because everything, the gravity itself, the pressure envelope you're contained in, all of that stuff has to be carefully maintained. And if anything goes wrong, it can quickly cascade into failure. Part of all of those things that you described are very definitely issues that would have to be faced by a crew trying to mine an asteroid in deep space. But there are also other issues, psychological, medical, geopolitical, legal. I touch upon the legal quite a bit, but there are many, many issues. And when it comes to mining, anything that somebody knows about mining here on Earth is almost completely irrelevant to mining in space. I always like to tell people, try to imagine mining a gravel pile that is in free fall and in a vacuum and in an environment that is both freezing in the darkness and burning hot in the sunlight. And you start to get some idea of what you're dealing with, because you can't start hammering at it or the material will fly away from you, and it gets very complex very quick. So that's what I was exploring with this.
And just like a follow-up to that question, was there anything that you discovered in your research that would make your hypothesis of mining impossible even, but that you intentionally overlooked in order to just write the story?
Yeah, actually, I love this question, because what I did instead was what I mentioned earlier, that when I set out to write this book, what really intrigued me, what I was trying to answer was, and it partly came from this idea that why aren't we in space? Why aren't we already on the moon and have a permanent number of people out there and growing industries? When I was growing up, this was during the space shuttle time. I mean, I as a very small child, barely remember the moon landing of Apollo. And I'm thinking, here we are half a century plus later, going on 60 years later, and not much has changed, really. I mean, sure, we're out, we have reusable rockets now, but a bit of frustration. So I started thinking, how would we actually make that big jump to becoming a celestial civilization? And I didn't want to hand wave. I really wanted to write a sci-fi story that was a bridge, if you will, that connects the present and crosses that chasm to that future. And that's what started my research. So I didn't start out with the idea, I want to write an asteroid mining story. Instead, what happened was I started to think, how do we get out there? And very quickly, when you talk to scientists and read research, you realize that the first thing we're going to need is mass on orbit. We're going to need some material to work with. We're going to need larger envelopes that have life support and electricity and all of these other things. How do we get that? And most people right now, I think, immediately say, well, the moon, we can get it from the moon. And as I cover somewhat in the book, the moon is a complex situation, legally, geopolitically, and otherwise. We're going to see in coming years as China and the United States, and to some extent Russia, and even India, start to land in and around the lunar south poles, and we start exploring with water. I think that's going to become a very touchy situation very quick, and that's going to have ramifications here on Earth. So part of what my billionaire in my book wanted to do was to sidestep all that by going to an asteroid. And when you start thinking about that, you quickly determine that there are near Earth asteroids that can be reached with less energy than the surface of the moon, which is extraordinary. At certain key points in the case of Ryugu, that date that they left in the book, that is very real. If you were to leave cislunar space on that date, it would be 48 days and that delta V to get there. That's less energy than to get to the surface of the moon. And of course, once you're next to an asteroid, you don't have to get out of that gravity well. And it is, if you've figured out how to mine it, it has a better resource mix that's more easily accessible. You can just pull the material apart and process it and things like that. Now that's oversimplifying because of course there are complications. But it was an interesting question. So I arrived at the asteroid mining, not because I wanted to tell a story about asteroid mining, but because that's where my research led me. So it was really the opposite. It was that the research convinced me that asteroid mining was eminently possible.
Mm-hmm. Yeah, that's really interesting. Just the whole resource gathering and making the economy wasn't actually what people had kind of been inspired to do.
Well, yeah, and the other thing is people always think that asteroid mining means you're going to bring platinum back to the Earth, which is not at all the case. The big virtue of this material is you bring it to the top of Earth's gravity well, because that's where we need material, is we need to start building a cislunar economy and heavy industry out there. I mean, a solar panel, for instance, if you can build solar panels out in space from in situ material that you get out there, a solar panel in space is 8 times more productive. I mean, that's extraordinary. I mean, it's going to be in sunlight almost all the time, because more direct sunlight, it gets more blue light. And if you can build these vast arrays, you will have ample clean energy. You can start powering carbon intensive industry up there. It's, to me, a very promising adventure to go on. And it could start the next golden age. And that's sort of what I wanted to give my readers a glimpse of.
Yeah. Hopefully we'll see it soon.
Yeah, well, you will.
Yeah. One last question.
Sure.
When I was researching, I found your really detailed SketchUp models of the Constantine.
Yeah.
Did you create this afterward to help market the book, or did you make them before to lead your writing? What did that look like?
No, I actually created them to help write the book. Because what happened was I realized that as I was starting to block out the story, the geography of the ship, where things were, the layout, all of that stuff became very important, especially when there's critical moments when time is a factor. I really needed to understand what my characters were going through. And that's what caused me to search around for the design of the ship. The inspiration for it was something called Clark Station, which was an aerospace project. I think it was an undergraduate project at University of Maryland. A group of students put together a spin gravity ship. What it was a station that would be in the L1, Lagrange point, EM-L1, Earth, between the Earth and the Moon, to do research on spin gravity, exactly the thing we started this interview discussing. And the idea was you would run it for a month with 1/2 gravity, or moon gravity, or Mars gravity, 38%, to see what the effects are of the occupants, take physiological readings. And then, of course, they could come right back to Earth because it's only a few days away. But that design intrigued me because it was addressing that issue. So that idea of 3 different radial arms, and you don't want to just have 2 like a bolo design, because those are inherently unstable. If you have 3, you can make them much more stable. And of course, it has to be of sufficient length and mass to stop precession and things like that. So that, again, I had some physicist help to make sure that I avoided those. But Clark Station was a real inspiration for that, for the SketchUp model that I did of my ship. And then, of course, I bring on board the honeybee robots and all this other storage. And it's really useful for me when I'm trying to construct a story and make it real, to see all of the architectural programming required in the ship and how it takes shape. And lo and behold, it looks kind of sci-fi and kind of cool, but I know why everything is where it is. And to me, that helps to bring some verisimilitude to the story as well.
Mm-hmm. They're both just really cool concepts. Yeah.
Oh, cool.
So that's all the questions I have. Thank you very much.
Yeah, it was fun. And like I said, these questions, I loved them because they were much more, intriguing than the questions I typically get, at least from mainstream publications. So I really appreciate that. I like the podcast too. I watched a couple of the episodes. They were fun. So hopefully this one works out. And thank you so much for inviting me.
Thank you so much for coming on to the show.
No, it's fun.
Thank you.
Take care.
You too. Bye.
Well, that was a really great interview. Thank you so much to Daniel Suarez for coming on the show. And as always, thank you for watching.